Now, let's look at one numerical associated with excess of loss reinsurance. Okay, individual claim amounts from a particular type of policy follow a normal distribution with a mean 150 and a standard deviation of 30. Claim numbers on an individual policy follow a Poisson distribution with parameter 0.25. The insurance company uses a premium loading of 70% to calculate the premium. Calculate the annual premium charged by the insurance company. Now, if I want the annual premium, I need to find out the expected value of S, which is an aggregate claim amount. So, which comes out as expected value of N times expected value of X. Expected value of N, Poisson distribution. So, the expected value is 0.25 times expected value of X, normal distributions, expected value is 150. 150 times 0.25 coming out to around 37.5. This is the expected value of S. Now premium is nothing but 1 plus B times the expected value of the claim payment. So which is around 70% more, so it is 1.7 times 37.5, right? So it is 1.7 times 37.5. The premium that is charged is 1.7 times 37.5, working out to 63.75. That's the typical premium amount that is coming up. Alright. Now, the insurance company has an individual excess of loss reinsurance arrangement with a retention limit of 200 with a reinsurer who uses a premium loading of 120% to calculate his premium. Okay. Calculate the probability that an individual claim does not exceed the retention. Means the probability that any single claim X is less than the retention limit 200. So I really want to find out this, and I know that X follows a normal distribution. So the probability that N of 150 comma 30 squared, this should be less than 200. So we can very well subtract the mean and divide by the standard deviation, convert it into a standard normal distribution. N01 less than 200 minus 150 by 30. So which gives me that the standard normal value should be less than 50 by 30, 1.67. I can try to find out what is the probability that n is less than 1.67 from the tables. Probability that n is less than 50 by 30. So here, okay, you can use the tables and directly get that. So because I am looking at less than itself, there is nothing, no other adjustment for me to look at. I am taking the cumulative, saying around 95.221% is the probability that n is less than. So this is the probability that individual loss does not exceed the retention amount. Only the probability of reinsurance, in this case the probability of reinsurance is only 1 minus of this, around 4.77% is the probability of reinsurance. 95% chance that the claim will be much below that retention limit itself. So that's how we can look at the second one. Then calculate the probability that for a particular policy in a given year there are no claims. For a particular policy in a given year, no claims which exceed the retention. So in a particular period, in a particular year, let's say there are J number of claims. So what is the probability that there are J number of claims, and what is the probability that each of the claim is less than the retention amount, right? Each of the claim. Now that J could be 1, 2, 3, so on, or 0 also. So that's where we are summing it up over Z to infinite. There could be anything up to infinite kind of claims, and I want to have the probability that each claim, because it is independent, each claim should be less than the retention amount. First of all, okay, what is the probability of having J claims? It's following a Poisson distribution. So the probability of having J claims is e to the power of minus lambda, lambda is 0.25, e to the power of minus lambda, lambda power J divided by J factorial. That is the probability of getting J claims. And for each of these claims, the probability of getting a claim which is lesser than 200. So the probability on one single claim, we have just a while back found out the probability that a single claim is lesser than lesser than the retention limit is around 0.9522. So for all the J claims, if they have to be lesser than retention limit, for each one the probability is 0.95 independently. And now this J could be either 0 or 1 or whatever. So I am integrating this case across the entire infinite. Now I could see if I take out as a simplification minus 0.25, if I take out, this is nothing but 0.25 to the power j, 0.9522 to the power j by j factorial, where j is ranging from 0 to infinite. Now you could see this, actually I could simplify 0.25 into 0.9522. So I can simplify it into 0.25 multiplied by this, around 0.2380. So this is becoming e to the power of minus 0.25. J is from 0 to infinite, 0.2380 to the power j divided by j factorial. Look at now substituting all this. If I put j equal to 0, it is 1. J equal to 1, it is 0.2380 by 1. Otherwise, it is 0.2380 squared by 2 factorial. 1 plus x squared by 2 factorial plus so on. It is nothing but it's an expansion of e power x. So this I could very well call, if I with the summation, I can call it as e to the power of 0.2380. So e to the power of 0.2380 multiplied by e to the power of minus 0.25. So this is what we can simplify. So the summation is going to be, or the multiplication is going to be e to the power of minus 0.25 plus 0.238, resulting in 98.81. So there is a 98.81% chance that for a single particular policy in a given year, there are no claims which are exceeding the retention limit. Only around 1.2% chance that the claims can exceed the retention limit. Okay. If that is the case, I really want to know what is the premium that is charged by the reinsurer. First of all, if I have to talk about the premium that is charged, I have to find out the expected claims. Right? So the claim which is charged, or what has to be paid by the reinsurer, if I am looking at The claim amount which is paid, I am integrating it over 200 to infinite. Okay, what is the amount that is paid by the reinsurer? X minus 200. This is the X minus M because 200 is the retention limit times f of x, which is the probability of occurrence of a claim, the original claim, which is having a normal distribution of a mean 150 and a variance of 30 square. So this is the typical scenario for a reinsurer. So which means I can very well try splitting this out. 200 to infinite x f of x dx minus 200 times integral 200 to infinite f of x dx. Now you see two things. This part comes out as a part of a special property. If I am having, in case of a normal distribution, if you recollect, x f of x dx, if I am having something like this, integrated between some L and U, this integration we have simplified it by using that special property for a normal distribution. We have actually computed L dash and U dash, where L dash comes out as L minus mu by sigma and U dash comes out as U minus mu by sigma. So I can form L dash and U dash, and so it gets I mean we can convert this into L dash and U dash, and this gets simplified to mean times phi of L dash U dash, phi of U dash minus this the cumulative normal distribution of L dash minus sigma times the probability density function of U dash minus the probability density function of L dash. This is the rule I can directly use. So this part I can simplify, and whereas this also comes out as, this is nothing but 200 times 1 minus of the probability of x less than 200, or probably you can say the probability of x greater than 200, which is 1 minus of the probability of x less than 200, which we have already computed as 0.95. Now this part gets simplified using this formula. The first term I can very well simplify it as mu times phi of, okay, what are my L dash and U dash here? L dash is nothing but 200 minus 150 by 30, which is 1.667, and U dash is nothing but infinite minus 150 by 30, which will continue as infinite. So we are calling the phi of infinite minus phi of 1.667 mu time minus sigma times, sigma is 30. Then we are talking about the probability density function of U dash minus the probability density function of L dash. Now this is the first term, and the second term for me is 200 times what is the probability that it is greater than, the claim amount is greater than the retention, which is around 0.04779, right? So this is what is going to work out on the expected claim amount. Okay, let's try out. If I have to get the expected claim amount by reinsurer, what is that number? 150 times phi of infinite. Yeah, phi of infinite is going to be 1 directly, minus phi of 1.667. So I can take norms distribution 1.667, or probably it is 50 by 30, comma 1. So this is one side, minus 30 times the small pi of infinite, which is 0, minus small pi 1.667. Now, what is the formula for the standard density function? 1 by root 2 pi sigma squared times e to the power of minus half, right? Or here sigma squared is 1 itself because it's a standard normal. So it comes out to 1 by root 2 pi e to the power of minus half x squared. Or if I say this is z, then it is half z square. So probably this works out to me 1 by square root of 2 pi times e to the power of minus half x squared. Here x is 1.667 squared. And then we have 2 minus 200 times whatever is this number. Finally, this is working out to this is working out to around 0.5931. That is the expected claim amount by the reinsurer. He is expected to pay a claim of around 0.59, but he is charging 120% as the loading. So the premium charged by the reinsurer is coming out to 0.59. This is the expected claim amount, right? And the parameter here is lambda. Lambda is 0.25, right? So we can very well look at multiplied by 0.25 times the loading is 120%, so 2.2 is what is coming into picture. So the reinsurer is typically charging a premium of around 0.3262. So this is the typical premium that is charged by the reinsurer. So in this whole thing, what is the insurance company's expected profit? So it has got an expected premium. Okay, let's see now expected profit of the insurer. So it has got a premium of 63.75. And out of that it is paying 0.32 as the reinsurance premium, and the expected claims that are getting the expected claims that the insurer is supposed to pay from the insurer's perspective is the total expected claim amount from the insurer's standpoint is nothing but out of the overall. So 0.25 times whatever was 150 minus this, right? This is the claim amount. On an average, the claim amount is 150. Out of that, I am expecting per policy the average claim is 150. Out of that, the expected claim amount by the reinsurer is 0.59. So the remaining is what is expected to be paid by the insurer, overall resulting in an expected profit of 26.07 for the direct insurer in this case. So a step by step workout in terms of solving this particular numerical.